Yeah.
Function.
It's the gradient function. Okay. Means the gradient function. Comes from what? What does the d stand for?
Delta.
Yes. Delta y over delta x. The change in y of the change in x. Yes. So change in y over the change in x. What does that mean? Well, when we go to our axis and when we get the gradient, we do rise, run. Yeah? And remember, the rise, if you have a formula, is y2 minus y1 and x2 minus x1 and the run. Remember that? Okay? So the change in y over the change in x. Let's just say we have a random curve. We want to know the slope at any one particular point. Yep. It was tricky to do to get rise over run at that particular point. So let's say it's a tangent here. We want to get, what's the slope of this tangent at this point? What's the rise over run of that tangent? It's kind of tricky to get if we just have the curve. So what we do is we think about getting kind of two points. And I'll make a line between them. And we get the x values. We just set the distance between the x values at h. X and x plus h. So we set the difference in the x values is just h. What's the difference in the y values? That's tricky. So we got to sub in to the x value in to get the y value here, which gives f, the function with x subbed in. And this one is the function with x plus h subbed in, because x plus h is the next one down the line. And to get the difference between those two, y2 minus y1, this is y2, this is y1, I just subtract. So it's just in general, what the rise is going to be. The function with a little bit more subbed in, take away the function with x subbed in. Now with this one, we could do that out. We can do the function with x plus h subbed in, x plus h squared plus 5 times x plus h minus 2. Take away this, all divided by h. And this is going to give me the slope anywhere along it. This gradient, we're not looking for a particular place, we're just looking for all the slopes along this curve. And this will work for any point. Once I know what x is, it'll work. And like if x is 2 or x is 5 or x is 10, they're going to give different slopes. But we'll have a function that gives us all those slopes. So let's work this out. We get x squared plus 2hx plus h squared plus 5x plus 5h minus 2 minus x squared minus 5x plus 2, all divided by h. Some things are going to cancel here, I think. x squared, 5x, 2, 2. And we're left with 2hx plus h squared plus 5h, all divided by h. Right. Which h can divide in, I think, to everything. So we get 2x plus h plus 5. Yeah? Now, we go back to the thing we did at the start. H was this distance. But we didn't want to get like this slope. We want to get an instantaneous slope at one like a point, if that line was a tangent. So really we want the distance between these two as small as possible. Almost zero to almost zero, so it's an instantaneous point. And that's where the concept of a limit comes in. As h goes to 0, but isn't 0, because if it was 0, we'd be dividing by 0 and it'd be a mess. But as small as possible. So if it was negligible and the 2 points were right on top of each other, the h wouldn't really matter. And therefore, the derivative or the gradient function for this is 2x plus 5. What does that mean? That means we can find the gradient anywhere along the function. So if we wanted to find, let's say, the slope of the tangent to y is equal to x squared plus 5x minus 2 at the point 7 minus 6. That mightn't be a point. That would not go through 7 minus 6. At x equal to 7, let's just do that. I'm not sure what. I just wanted to use 6, 7. Well, yeah, jokes. Okay, so that is asking when x is 7, so somewhere down the line here, when x is 7, what's the gradient of the tangent at that point? If there was a line that was a tangent, what would be the gradient? And if we were in an exam, well, we wouldn't do it from first principles. We would do it by power rule. We get, oh, I need the gradient function. What's all the gradients along this? The change in y or the change in x for this function is from the power rule 2 times 1 here in front, which is 2x, 1 times 5, which is 5. Take away 1 from this power, 0. So the x got, oh, we had it already, but that's from the power rule. The 2, the constant, will go away, because as we saw, the constants always cancel out. So we have this gradient function. This will give us the gradient anywhere. Oh, at x equal to 7, oh, I'll get it exactly. What's the gradient? 2 times 7 plus 5, so that's 19. So the gradient of this line, that's a tangent at this point 7, that gradient is 19, which makes sense. It's quite a steep slope.
If you knew, could you be asked to draw a graph based on the gradient alone?
Yeah, so we could draw this gradient. What does this gradient look like as a graph? That's a great question. So crosses the y-axis of 5, yeah? And it's a rise over run of 2 over 1, so it's going up 2 and 1, yeah? So this is the gradient function, what it looks like. Am I right?
Yeah.
So the gradient function can be f dash x sometimes, or dy over dx. That's the change over y, change over x. It's just when it's y, and f dash x, just a quicker way of writing it, is 2x plus 5. Let's consider what this means compared to that. Is something wrong? Well, my thing is that this isn't the correct graph for that. So let's draw the correct graph for that. That was a sketch for just a random. I think this one would have x-intercepts, maybe? Can we find out how to draw this graph? What would we do? Put it in a calculator? Yeah.
What's it called? Quadratic?
Well, what's the test our knowledge of vertex? Well, what would be the axis symmetry? What's the axis symmetry here? Minus b over 2a.
So 5 over 2.
Minus b, negative 5 over 2 is the axis symmetry. So negative 2.5 is the axis symmetry. All right. Where is this line cross the x-axis?
5 by 2. Yeah.
Oh, right. Okay. So the axis symmetry, so this is going to be a happy face graph. The axis symmetry is, we know, minus b over 2a. So the axis symmetry is y is equal to, or x equal to, I can't remember. Which one is it? Oh, that's right. X equal to, I'm just making sure. Minus 5 over 2. All right. Now, it's a happy face graph. Does it sit up here? Does it have, many roots does it have? How do I test how many roots it has? Discriminant. All right, that'll test how many roots it has. So b squared minus 4ac tells me how many roots it has. 25. Take away 4, 1, negative 2. How many roots does this have? More than 0, okay. So it's down here somewhere. They're probably going to be not nice numbers, but this is my estimation. Okay. It might. Okay, this is my estimation. If we thought about it more, we'd get it. Or we could just solve it. We could get it. Okay. Look at those two functions now. So I'll just go over this. The gradient functions here now in red. Okay. Discussed why this and this are in line. Why are they in line? So this red line tells me all the slopes of the blue line. Yes. The red line.
The slope at that point is 0. So it will be 0 at that point. Like it'll go through.
Yeah, think of the slopes of this blue line. This is like downhill, 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 downhill. 0 it must be flat here. Uphill, 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 uphill forever, yeah? And how that relates to this line, the red line, yeah, all the y values past this point are positive, aren't they? All the y values, so they're all positive y values. And all the y values before this point are negative. And at this point, they're 0, which matches that one.
So you can use that as instead of axis of symmetry.
Yeah, you could find the 0 of this, let it equal to 0. And what will it find? When we let the first derivative equal 0, what do you think we find then? So when f dash x equals 0, so when this line is 0, what did we find? We found negative 5 over 2. But what we found geometrically? What point was it on the other one? No, it was down here. It was the x-intercept on this one. So that's what this said. This is the x-intercept is what on the other one? Axis of symmetry, yeah.
Oh, the minimum?
The minimum, yeah. Yeah. It's the minimum point.
Oh, that's one of the most
Yeah, we're not there yet, but that's just interesting. We'll come back to that. Now, what we need to do is do more of just practicing how to get by power rule and stuff like that. No, that's frozen. So let's have a look at some questions. I'll do one or two, and then you guys can get stuck in. So these are all about getting the gradient of a tangent.
But you said these weren't for us yesterday.
Did I? I don't think I did. All right, so let's look at h here. Here's my function. Y is x cubed minus 4x minus 8 over x squared. So if you're someone like Yoop and you've worked ahead, then you might know the product rule, but we don't know the product rule yet. And at x equals minus 1. So this is some curve. I don't know what it looks like. I have an idea, but and at x minus 1, we just want to see how steep the tangent would be. So we got a curve, let's say it's just like this. At x minus 1, I want to know what that tangent's going to look like. Okay, so I need to get the dy over dx, the change in y over change in x, or slope in general of this, or gradient in general of this. How do I do that?
Separated.
Yeah, separated. Divide x squared into all these. So before I need to do a little rearrange before I can even derive. Am I right by saying it's x minus 4x minus 1 minus 8x minus 2? I left it like this and not put the x underneath because I can use the power rule when it's like this. So my derivative function or gradient function is, what's the derivative of x? Nice, 1. What's the derivative of this? Yep, and here? Plus 16x minus 3. So multiplying down. I like to then write it like this because it's much easier to substitute in when it's written like this. What am I substituting in? Negative 1. So this will give me all the gradients, but I only want the gradient at negative 1. So I sub in negative 1. 1 plus 4 over negative 1 squared plus 16 over negative 1 cubed. What's my answer?